So for today, we are starting a new unit. Okay, we are actually going to skip Unit 5, and we'll come back to it at a later time. But we're going to start on Unit 6 today.
Why are we skipping?
We're skipping because the way the calendar falls, we would have had to do part of a unit and then be on Thanksgiving break, so we moved a shorter one up. And this one's a little bit shorter.
Don't we need to know stuff from Unit 5 though, for Unit 6?
Nope, you don't. They do not build on one another. So, we are starting on Unit 6.1 today. And Unit 6 is all about rational exponents. Okay, so today, enough. Okay, today we're going to evaluate something called nth roots. Guys, hello. Evaluate nth roots. We will come back to it. It's longer, so we're doing something shorter before we go on Thanksgiving break. Okay? What? Evaluate nth roots, okay? It's not cube roots, it's not square roots, it's not fourth roots, okay? These are called nth roots. So evaluate nth roots and use something called rational exponents.
This is the singular rational.
Okay, rational actually means what? Does anyone know what rational means in math?
Whole numbers?
In math, rational means fractions, okay? So we're going to use fraction exponents. So, converting between forms, okay, is the first thing we're going to work on. Converting between forms. Okay, there are two different forms that we are going to be using for this unit. The first one is called rational exponent notation. Converting between something called rational exponent notation and radical notation. Okay, rational exponent notation and radical notation.
Oh, okay.
Good. Okay, rational exponent notation. So you're going to see something like a to the p over h power. A to the p over h power. Okay? The way that we change this into something called radical notation is it's going to be in radical notation as in parentheses, in a radical. This is called a radical. It's not called a square root. Okay, we call it a radical because sometimes it has different numbers in this handle. The a goes here, the p goes on the outside, and the h goes right here. And I'm going to show you why those work right there. Okay, the p in this equation we would call the power. Okay, so p stands for power. Okay, this is the power when you convert it. The h is what I would call the handle number. Okay, this is the handle. And it belongs in the handle of the radical. Once you can convert between the two of them, what we're doing today is fairly simple. Okay? Most of the difficulty here is just converting between the two forms. Yes.
What do we use this in?
We're getting there.
Okay.
I'm getting there.
Okay.
Calm down. Okay? You are also going to see some things written in negative exponent notation. Okay? So something like a to the negative p over h. A to the negative p over h. What's the first thing you have to do whenever you have a negative exponent?
Flip it.
Make it a fraction and then move it to the bottom. So this would become 1 over a to the p over h power. Notice that we move the whole thing, but you do not flip these. Okay, they still say p over h. They do not flip over. Okay, this would become, if it gets written in radical notation, this becomes 1 over a underneath the radical. Your p for power is on the outside, h is in the handle number. You're not going to have too many that are in negative form, Okay, but you do need to know how to do that just in case. So, some kind of, I don't want to say rules, but examples of what could happen, okay? So, some guidelines that you are going to follow. Okay, guidelines I want you to follow. If we have a radical, okay, if we have a radical, and I have a positive number underneath with an even handle number, okay? So an even handle number with a positive, that will equal both positive and negative numbers. Okay, you will have both positive and negative numbers. Okay, so let me show you that with numbers, okay? Something like root 16. What is the handle number in root 16? Do you know? 2. Okay, if it's not written there, we always assume that we're looking for a pair. It's kind of like if I ask you how old you are and you tell me 16. You don't have to tell me positive, I just know it. Okay, it's a given. This is a given handle number. So this, we assume that if nothing's there, it's a handle number of 2. Whenever you introduce a radical, you have to write plus or minus in your answer. So the answer here is actually plus and minus 4. Okay, that's a little shift in thinking from what you may have done before. Okay, so that's one type of question you'll see. Another type of question you'll see is if you have a negative number underneath. If you have a negative number underneath with, again, an even handle number, okay, in this case, you'd have something like root negative 16. Okay, what would you assume is the handle number here? A 2. What is the square root of negative 16? Does anyone know? What multiplied by itself gives you negative 16? Doesn't work, okay? This is something we would write as no solution. Later in the year, okay, later in the year, I will show you how to do these types of problems. But for now, you write no real numbers, okay? No real numbers. This has something to do with something called imaginary numbers. We are not there yet, okay? So for now, it's just no solution, or you can write no real numbers, okay? You basically don't have to do those types of problems. The next type of problem you'll see is again with a root, okay? This time if you have a positive number underneath your radical, and this time if you have an odd handle number, okay, an odd handle number. So an example of that would be something like the cube root of 27. Cube root of 27. What multiplied by itself 3 times is equal to 27? A 3. So if you have a positive number underneath and an odd handle number, what do you think you know about your answers? Will they all be positive or all be negative, or would you have both? Any ideas? It will always be positive. Okay, so if you have a positive number underneath, regardless, okay, if you have a positive number underneath, you're always going to get at least a positive answer. And then the last type of question that you'll see is if you have a negative number underneath, negative underneath your radical, with an odd handle number. So something like the cube root of negative 27. Anyone know what is the cube root of negative 27? What multiplied by itself 3 times give you a negative 27?
3.
Negative 3. So anytime you have a negative underneath with an odd handle number, you will always get a negative answer. Always. You will always get a negative answer. So these are kind of your guidelines that you're always going to follow, okay? If you have a negative underneath and it's an odd handle number, you get a negative answer. If you have a negative underneath and it's an even handle number, it's no solution. If you have a positive underneath with an odd handle number, you get a positive number. So anytime you have an odd, you basically, your answer will be whatever's underneath, okay? The same sign as what's underneath. Where it's different is when you have even handle numbers. So positive with an even handle number will give you a plus or minus. Okay? Once we get into more numbers with these, it will become a lot easier. So, what you're actually doing today is the questions are going to ask you to evaluate. And evaluate basically just means write it in the form that you can do. Okay, so we're going to rewrite these in a usable form. So something like 16 to the 3/2 power. 16 to the 3/2 power. Do you know, just in your head, what is 16 to the 3/2 power? Not really. This is not a very usable or user-friendly way to write this, but I can rewrite it. Okay, I'm going to rewrite it in power handle. So here, write your radical. The 16 goes underneath. Okay, this is where it can get a little bit confusing if you're not paying attention. The 3 is the what? Is it the power or the handle?
The handle.
That's the power. So the 3 goes out here. The 2 is where your handle belongs. So the 2 goes here. Okay, as long as you get them in the right place, these should be fairly easy. Then, what is the square root of 16?
4.
4. And take that to the 3rd power. So you always do what's inside the parentheses first. So this would be 4 to the 3rd power.
64.
And what is 4 to the 3rd power?
64.
4 times 4 times 4 is 64. That's the answer that we're looking for. So all of what you're doing today is just converting things and then simplifying, basically. Okay, try another one, number 2. And we're going to do 5 of these. For number 2, 32 to the negative 3/5 power. 32 to the negative 3/5 power. Automatically, first thing you should do when you see a negative exponent is what?
Flip it.
Make it a fraction. Okay, so 1 over 32 to the 3/5. You do not, this changed to be positive, but you don't change where the 3 and the 5 are. Then we're going to rewrite this so it still says 1 on the top. Okay, underneath your radical, we put 32. These are always going to be in parentheses. Where should your 3 go? Is 3 the power or the handle?
Power.
This is your power. So I'm going to write P for power on the outside. The bottom is your H for handle, so that's a 5. Then we have to figure out what to the 5th power. So the 5th root of 32 is what? What multiplied by itself 5 times gives you 32? In case you don't know, there's a chart on the back in the Math 8 section. Okay, it has a bunch of exponents on there. This is 2 to the 5th. So if you broke this down, this would be 2 times 2 times 2 times 2 times 2. So the 5th root of 32 is 2. You will get used to these, okay? You will kind of memorize them. Then I have to take this to the 3rd power still. And what is 2 to the 3rd power? That's basically 2 times 2 times 2, which is what? 8. So 1 over 8 is the actual answer that we're looking for. 1 over 8. You will probably get really good at your powers of 2. You'll just kind of memorize them because we use them a lot. Okay, number 3. I'd like you to simplify 125 to the 2/3 power. 125 to the 2/3 power. First thing you want to do is rewrite this in power handle. So underneath the radical is 125. Power of what? 2. Handle of 3. So make sure you put the power and the handle in the right place. Then do what's inside the radical. So what's the cube root of 125? 5. And you're going to take that to the 2nd power. So 5 squared is equal to what? 25. That's your answer. Anyone have questions so far? Okay, let's try another negative. I have 2 more and then we'll be done. Number 4, let's try 8 to the negative 4/3 power. 8 to the negative 4/3 power. 8 to the negative 4/3 power. What is the first thing you should do?
Fraction.
Rewrite it as a fraction. So 1 over 8 to the positive 4/3. Don't lose this 1. A lot of people lose the the numerator there. Don't forget, there's still a 1 there. Rewrite this in power handle. So 8 to the power of what?
4.
Power of 4, handle number of 3. And these are all going to be really nice numbers, okay? Notice that, like, we know exactly what the cube root of 8 is. We knew exactly what the 5th root of 32 is, okay? These are kind of done on purpose so that you're not going to get super weird fractions and decimals and stuff. So 1 over, what's the cube root of 8? 2. And take that to the 4th power. What's 2 to the 4th power? So 2 times 2 times 2 times 2? 16. So 1 over 16. So you do need to rewrite these with no decimal, or excuse me, no exponents. And then the last one I'd like you to try is for number 5, the cube root of negative 8. What is the cube root of negative 8? What multiplied by itself 3 times is equal to negative 8? Look back at that chart if you need to. Odd handle number, negative number always produces a what? Negative answer. So what multiplied by itself 3 times would give you 8?
Negative 2.
2, since it's negative, negative 2 is your answer. Okay, and if you want to check your work, that works. Negative 2 times negative 2 times negative 2. Okay. Homework for this is going to be on page 417. You're doing page 417, numbers 3 through 6 all, 7 through 13 odd, and 21 to 33 all. Okay, so that's in your book. Page 417, numbers 3 through 6 all, 7 through 13 odd, and 21 to 33 all.